Testing, test. Oh, yeah. Okay, now you can hear me. Now I can hear me, which is really disturbing. Um, yeah, while we're just waiting for everybody to get their laptops open and things, if you can make sure you have IPython 3 or later installed, um, there are instructions for doing that on the IPython website. If you have any trouble with it, then wave at one of us and we will come and give you a hand. And then clone this repo, which contains the materials we're going to be working from today. Version, do IPython in a terminal space dash dash version, and it should tell you what version you have. Okay, I'm going to assume that you've all got the repo cloned now and IPython installed. If that's not the case, please stop me now. Okay, one's still working. Anyone else? Two. Okay, there are a few people still getting that fixed, so we'll just give you a couple more minutes and we'll wander around and help. Okay, so hopefully just about everyone is now up and running or on their way to being up and running. If you're not quite there yet, then please keep plugging away while I start talking. So if you get a terminal, cd into that directory where you've set things up, where you've cloned this repository, and type IPython space notebook, then if everything is installed correctly, that should start the notebook and you'll get a page looking like this. So this is what we call the dashboard. This is just kind of the overview of the files and folders in that folder, and you can see that it's sorting the .ipynb files, the notebook files first. And if you click on index basic, then this is kind of the overview of what we're going to be going through today. So I'm going to kind of super quickly go through like what notebooks are and how you use them, because I imagine that quite a few of you will already have used the IPython notebook to some extent. So I want to kind of make sure everybody's on the same level, but I don't want to spend too long on that because it's probably not interesting for everyone. And then I'm going to go through some of the kind of the features of IPython that were there before the notebook and they still work in the notebook. And again, I'm sure some of these will be things that you're familiar with, like tab completion. Some of them maybe you're less familiar with. Then the interesting things that I want to get to are the rich display system. So how you do like output that includes graphs and tables and things beyond just plain text in the output, and sort of how you can integrate that with your own objects and things, that you can have objects that display nicely inside IPython, and the widget framework, which is kind of an extension on top of the rich display protocol to like allow the representations of objects to talk back to the objects on the Python side so you can interact with them. Then there is going to be a coffee break about halfway through the session, and then I'm going to hand over to Kyle, who's going to talk a bit more about some of the stuff that we're calling Jupyter. So IPython is branching out. We're moving into other languages besides Python itself, and in consequence of that, it's become quite awkward trying to explain this to people because it's called IPython. People think that it's all about Python. So we're renaming the language agnostic parts of the project to Jupyter, which still has the PY in there. It's kind of roughly based on Julia, Python, and R, even though it will handle other languages beyond just those three. And the bits specific to running Python code will stay as IPython. And then there's also going to be a bit about how you can deploy like IPython notebooks on a public website and some of the tools we have for doing that. So launching into notebook basics. So a notebook is a document. This is an application that runs with the interface in your web browser. And so there are kind of two things that we call notebook. So there is the notebook application, which you use to write notebooks, which admittedly is not the greatest naming, but we haven't come up with anything better yet. So this, like the whole window is the notebook application, and this kind of white page within it is the notebook document. And this is something that you create. So this grey border here indicates that I have a cell selected, and at the moment that's a markdown cell, and that's rendered. But if I press enter there, that goes into its unrendered state, and here I can type raw markdown. And you can see it does some level of syntax highlighting as I type, and then when I press shift enter, that goes back to the rendered state. This has already told you, this is telling you a bit about the dashboard, which we just showed. That screenshot is actually from an older version of IPython. So if your dashboard looks like this, then you're running an older version of IPython and you're going to run into trouble later. So make sure you upgrade before we get to some of the later parts of the course. So you can see that the notebook application has a kind of a fairly traditional UI, even though it's within a web browser. There is still a menu bar with your standard sort of file, edit, etc. menus, and these have standard options like open and save, well, give or take a bit. And we have a toolbar, which is like the most common options from the menus. So here's save, here's add a new cell. So if I click here and click the add a new cell button, a new cell appears. And I can also cut that cell. And we do have an interactive UI tour that does the pop-up tooltips, and it even looks like it's working at the moment, which doesn't always because we don't check it very often, but you don't need to look at that because I'm going to tell you the same things today. So as you may have noticed as I was doing that, there's two modes to the interface. So while I have the grey border around the cell, I'm in command mode. So it's a bit like Vim if you've used Vim, but hopefully not quite as hard to get your head around. So at the moment, like my arrow keys are moved between the cells, and if I press A here for insert cell above, then it inserts the cell above. If I press B, it inserts the cell below, and to delete a cell, I'm pressing DD. So we make you do it twice because it's a destructive action. So DD, just to confirm that you know what you're doing. And then if I press enter, I go into edit mode, and that makes, with a markdown cell, that makes it go unrendered, so you can see the raw text that you're editing. And now my up and down move within the cell, and if I press A, it just inserts the letter A. So with markdown cells, it's important to note you can actually go into command mode and leave the cell unrendered. So I'm now in command mode, and I go back to that cell and press shift enter, and that's now rendered again. The reason that the interface wound up like this is we did try to do it with like control thing, keyboard shortcuts, but within browsers, like different browsers and different operating systems have already taken just about every combination of control something keys. So there was nothing we could use without people complaining that it overrode their browser shortcut for something or other. So now I think Control S is the only one we have by default, because browser save on a notebook page is almost useless. So yeah, there's command mode, and as it mentions, if you have a cell, so this is a code cell which we'll come to in a moment, and you try to type there, then either nothing happens or the wrong thing happens. So here I pressed H, and the help has popped up instead of entering an H. And you can always move between them by enter takes you into edit mode, and escape takes you back out to command mode. So you get used to doing those two quite a lot. Just do DD again there to remove it. So it's often most convenient to use the keyboard shortcuts, but you can also do everything with a mouse. So if you click on a markdown cell, it selects it, and if you double click on it, then you go into edit mode, and if you click, so while a markdown cell is unrendered, then clicking inside it goes to edit mode, and clicking outside the typing area goes to command mode, and this play button or run is what will take that back to rendered. And here's the keyboard shortcuts, which I've already been talking about. So these are lists of available shortcuts. This is also always available if you go to help keyboard shortcuts. and it doesn't display very nicely at this resolution. Normally on a real screen, if you do that, you should see it in 2 columns, which makes it a lot easier to read. And the shortcuts are broken up into the things that work in command mode and the things that work in edit mode. And there's much fewer of our own shortcuts that work in edit mode, but there's quite a few shortcuts for CodeMirror itself. Sorry, CodeMirror is the little text editor that we use inside the cells. And these are kind of this is an easy order to learn them in. So the basic navigation shortcuts, so enter to go into edit mode, shift enter to render or run a cell. From command mode, S saves the notebook. You can see it says checkpoint created. It's just disappeared again. There we go. So switching between cell types, M makes the cell a markdown cell, Y makes the cell a code cell, and amazingly this notebook has not actually managed to include any code cells yet, but that's kind of probably the most important bit of notebooks, which is if you put this cell in code mode, then you can start typing Python code, and when you do shift enter or press play, then that Python code runs, and if there's any output, which in that case there wasn't, you'll see it. And you can also have, this isn't limited to one line here, you can have multiple lines if you remember to do it. So if I press enter there instead of shift enter, then I get a new line, and I can then 1 to 6 are now convenience options. So these do different levels of heading. So heading level 1 is the biggest, and you can put it at different levels by pressing 1 to 6. That was originally different types of cells, but we've now made them all markdown cells. X, C, and V do the cut, copy, and paste, like Control X, Control C, Control V, just without the control. So there's X, and I can put it in there. So V is paste below, DD for delete. When you're inside a cell, you can do, I believe it's Control Shift Dash. Yes, there we go. So that is that splits a cell at the current cursor. So you can separate a cell into 2, and there isn't a keyboard shortcut for merge, but you can also edit, merge cell above, bring them back together. And then, so the last ones on here are for controlling the kernel, which is the process that's sitting in the background actually running your code. And so if I just make this, so I can start running something, and then I twice, in fact, II will interrupt it. So that's as if I'd pressed Control C at the terminal while something was running. And if I want to clear the kernel state and start again, I can press dot twice, I believe. Dot. Why is that not working? Okay, I think we changed that shortcut since this notebook was written, evidently. Is it 0? Yes, there we go. It's 0, 0 will restart the kernel, like 0 everything out. And so if so there I have A defined. If I restart the kernel and it asks me to confirm because that's throwing away all of the variables in that. Then now if I look at A, it says A is not defined because I've restarted it since I defined A, and you see that the number here has gone back to 1, so that number keeps counting up within the kernel as long as you're running more code, and then when you restart the kernel it goes back to 1, so that's kind of an easy way to tell what's going in and out. Okay. So, going through the kind of IPython features, so you can run any Python code within IPython, but IPython also kind of extends the syntax a bit in various ways to make it more convenient for interactive use. So here's some plain Python code running. You can see that I'm doing this in Python 3 because so I have the brackets for print, but all of the same things should work if you're doing it in Python 2, and it should tell you can see up in the top right corner, it will tell you what version of Python you have, and in fact if you're using another language that will switch to say what language you're using. So just typing question mark by itself will bring up the kind of IPython overview, which you don't need to read now because again I'm just about to tell you a bunch of this stuff, but that's an easy way to get this information back at a later point. So one very useful, like one of the biggest reasons that people use IPython is or at least before the notebook, is this. You can just add question mark to any name. So here we did collections.name tuple question mark, and it tells me the help about this. So here it's got the signature of that function or type, and then the doc string. And if you go down to the bottom, it will have other useful information like what file that's imported from and what type of object it is. And if you go a step further and do double question mark, then it will also show you the code for that object. So this only works for Python code. If you have a compiled C extension that you're loading in, then it won't find the source code for that. But for Python things, any function or any class, you can just do double question mark and have a quick look at the source code, which is enormously useful. You can also, I don't use this one as often, but you can use the question mark together with asterisks for wildcard searching. So *int* question mark finds everything in my current namespace that has the letters int together in it. And you can also do this at multiple levels. So I can search within NumPy and it will tell me everything a level below the NumPy package that has int together in it, and there's quite a lot of those things, it would appear. And so quick ref is another way to kind of get information about what IPython can do quickly. This is in a kind of very condensed format that just reminds you of these different syntaxes. And this is one example of a magic. So these commands starting with % are kind of special IPython interactive commands, and there'll be quite a few more of those later in this document. So tab completion shouldn't be terribly new to anyone by now, I'm sure, but if you press tab after you've started typing something, it will try to find all the ways that that thing might finish. I think this is now actually built into Python 3.4. If you go into the plain Python interactive shell, you have the same feature. So in the notebook, you can select one of these and press enter. It will also complete file names. So if I do open something and then start typing a file name, it can complete that. So here, let's evaluate some plain Python code, and then the last output is always stored as this underscore variable. This one again is actually the same in plain Python. So you can kind of like do a series of calculations building on the answer from the last one, just using underscore. And if you put a semicolon at the end of some calculation, that suppresses the output, and so it's neither displayed nor stored. So my underscore now is still 22, not 30, as it would be if this cell number 11 now had been used to update it. It's also, each output is stored in, so these out square brackets numbers, they're not just there for kind of decoration. You can actually use that as a Python variable. So out is a dictionary and it's keyed by the output numbers. So out 10 is in this case the number 22, and it will be whatever object was the output of that cell. And it's also stored as underscore 10 as a variable, just for greater convenience. So you can see it's 22. And going kind of beyond just the underscore for the last one, you also have underscore, you also have double underscore for the last but one and triple underscore for the last but two. We don't go further than that. That's really, by the time you get to 3 underscores, it's getting really hard to read anyway. But that's, again, extra handy features. And the same as with the output is stored in these out variables, the input is also stored in square brackets number. In this case, it's stored as a list rather than a dictionary because every input is guaranteed to be there. So I can say in 11, and this run through the notebook, in 11 is this cell, and the inputs are stored as a string. And then similarly to outputs, the last input is stored as underscore I, and the last but one input is under II and under III, and beyond that it gets silly, and I think they all under, yeah, so they're all also underscore I number, the same as doing like in square brackets number. We have many ways to get to those things, and you probably only need to use one, but depending on what you like, you may choose a different one. We also keep a record of all your history that you can look through with magic commands. So this %history -n 1 to 5 gives you the first 5 inputs from this session with their numbers. That's the -n. We'll skip over the exercise here because I think there's more interesting things to get to. We actually keep all of the history from everything that you type into IPython, so it's not just the current session. Like everything that you've ever typed into IPython since I think version 0.11 is recorded in an SQLite database in your home directory. So there is a -g option that you can go and search through all of that if you vaguely remember doing something and you typed some keyword into it and you want to find the rest of it. It's all still there. Then there's also bang commands, so commands that start with an exclamation mark. These are just shell commands that get passed to either bash on Linux and Mac systems, or not bash, but whatever your default shell is, which in most cases will be bash, and the command prompt on Windows. So you can just run arbitrary commands, and also kind of, to my mind, this is mostly a party trick, but you can take the output from a command like ls and store it into a Python variable. So you can do files equals bang ls, and then files becomes, it's a list split on the new lines. So you can then work with that list of files in your IPython code. Yeah, I haven't come across many situations in which that's useful. It mainly seems to be used with ls to get a list of the files, which you can do fairly easily in Python anyway, but sometimes it saves you a bit of typing. And here you can then use those Python variables back in a system command by surrounding them with the Kelley braces. So that forces it into a string and then fills that in with the system command. And you can even do this inside loops and things. So here we have a Python loop, so it's iterating over the files, and then if the file ends with IPython, it will print out something, but using bash to echo that thing. And if it doesn't, then it will print out a placeholder using Python. So you may have noticed there's a little bit of, it's noticeably slower doing that than running the same thing in pure Python, because each time you do this bang echo, it is starting up a new bash process in order to echo that output, and then killing that bash process again, or at least the bash process is dying of its own accord. So there is definite overhead in doing that, but again, there are some things for which it can be very convenient. Yes. Yeah. So it's not, you can't just use it as an arbitrary Python expression. The only things you can do with it are you can have it on the whole line, so it's just like send this to bash, or you can put like variable equals bang something. So then magics, we've touched on magics a couple of times before. So the general syntax is percent and then the name of the magic. I think percent magic is a magic that gives you information about the magic system. So there's like single percent magics run to the end of the line, like the bang commands that we just talked about. So here, timeit will loop over running this code some number of times in order to measure fairly accurately how long that's taking. And then if it's double percent, then that has to be on the first line of a cell, and that then evaluates to the end of the cell. So in this case, this timeit is timing both of those commands together. So that's the distinction between line and cell magics. And again, you can use line magics inside a code block, so it gets transformed into a line of Python code. Sorry, I just noticed that my shoelace is undone. Cell magics you can't use inside Python code. Oh, thank you. You can't use cell magics inside Python code. Because they have to be the whole cell. So in the timeit examples, the input, those magics, is all Python code, but it doesn't have to be. There's no restrictions on what you can put after a magic. So like one thing that we do a lot with cell magics is we have a cell magic so you can execute some other type of code within the notebook. So this is the bash cell magic. So this is like you put a little bash script inside a cell and put %% bash at the start of it. We have magics for R, for Python, for Julia. There's all kinds of languages that you can put in a cell like this, and with some of them, like for R, you can even give options to the magic to say, like, I want to move these variables from Python to R before running this R code. So you can kind of shuttle things back and forth between languages. Another cell magic that we have is write file. So that just takes the contents of the cell and writes it to a name that's there on the first line. And then we can use bang cat. So this is a system command to read that again. And ls magic is just a magic that tells you all the available magics on your system. So you can see we have quite a few line magics and rather not so many cell magics, and many of them are concerned with running code in other languages. Yeah, briefly, so you can, if you copy and paste code from examples and it has the like Python interactive prompts or the IPython prompts, IPython is smart enough to recognize those and discard them, so that code will still run as normal. And we have some nicer trace backs. So instead of the just like little compressed Python trace back, we take up a lot more space and we have colors, and it shows you more lines of the context. And if you it's not in this example. You can also, if you switch the exception reporting mode, then you can also get even more detail. Oh, I think, no, we have turned it on here. So this is actually telling us like what the values of variables in those traceback lines are. That doesn't happen by default, so we've turned on somewhere here. Oh, I'm a bit lost. Okay, yeah, there. Xmode verbose turns on this extra information about the variables in those functions, and the default is context, which shows you more like this. So you see extra lines, but not the variable values. And yeah, here's some more examples of running code in other languages. So we can run some Perl code. Not sure why you'd want to do that, but you can. You can run some Ruby code. Not sure why you'd want to do that either. You only need Python code, right? Yeah, I think this is probably a good point to have the first exercise. So have a go at writing a cell that runs in bash and prints out your current working directory and the date. Oh yeah, this might be tricky for Windows users. I think it should be possible to do the same thing in Windows. I don't know exactly how though. And yeah, so if you run this, then you will see the solution to it. So have a go, like make another cell here, B for insert cell below, and have a go at the solution yourself before you look at the answer. And we will wander around and see how you're getting on, and we'll resume in 5-10 minutes or so. carry on. So if we look at the solution there, then we made a change to the way that works. So if you get rid of the comment line, then the solution, it's just a cell with %% bash at the start, and then you can use the bash date command and the echo command to show what the working directory is, or you can use just the command pwd, which is print working directory. So we can, another handy feature is when you get an exception, you can do %debug, which will drop you into the PDB interactive debugger, and you can move around the stack and look at what went wrong here. And then I think it's Q to get out of that. Make sure that you do get out of that, because otherwise you can't do anything else until you've left the debugger. And that's interesting. And you can also, so the standard input or raw underscore input if you're in Python 2 will work with this. So you can type in something and that will get sent back to the notebook. And again, the way this works is while that input box is shown, you can't do anything else. That blocks the execution of all your code until that comes back with the answer. And you can also do plotting in lines. If you have matplotlib, you can follow through this example, and this matplotlib inline magic command tells it to put the plots from matplotlib inside the notebook itself. So there's the output appearing. And okay, we'll skip over this for now, I think, because we're going to touch on that more later. Okay, so this is the bit that I really wanted to get to, is the rich display system. So you saw there that we had a plot appearing as output in the notebook, and this is something that you can do more generally. It's not just matplotlib plots. There's a system where you can give any object, whether it's an object that you're defining or an object that's already defined, custom representations for different formats. So you can do HTML formats, PNG images, JPEGs, SVG, vector graphics. You can do LaTeX. You can do bits of LaTeX within the notebook. But also part of the design of this is that if your object can represent itself in multiple ways, then all of those will be stored in the notebook. So like if you have an object that has an HTML representation and a LaTeX representation, then you can generate both of those and they'll both be stored in the notebook. And then if someone later converts that notebook to LaTeX, then it can use the LaTeX format in preference to the HTML format. So each thing that is displaying or using the output has a kind of order of priority of like what output formats it can deal with best. So in the notebook, like HTML is the preferred one because HTML is kind of the native language of the notebook application. But if you convert this document to something else, it can prefer any of those other ones. So we're going to start off by importing from this IPython display module. And yeah, I've just talked about the different priorities. So the display function will try to like calculate and send all of the possible formats, and then let the front end, in this case the notebook application, pick which one it wants to show. You can also use any of these explicit functions which tell it to use a specific function. So for historical reasons, display pretty is what the text representation is called, because that was like pretty printing from before any of this machinery was around. But if you want to force it to display the PNG representation of something, for example, you can do display PNG. So those are all functions that will take an object and try to like calculate its representation and send it to the front end. Then there are a collection of classes which you can use, and these can like load data and these classes know how to display themselves in particular ways. So here is an image class. So when I say here I'm instantiating an image object, and it's not displaying it because I'm just assigning it to a variable. But then if I just put that variable at the end of a cell, like putting just a plain Python expression at the end of a cell, then it works out that there's a better representation available and displays it automatically. And if I go and inspect this element, we can see what it's picked up for that. And in this case, it's displayed it. It's picked a PNG representation of it, and so that the PNG actually ends up in line in the HTML the way we do this. Yeah. So if you, like in a case like this where you know the image name, the image is in a file and you know which file that is in advance, then that works. If if the image is being generated by your code, or there's a selection of images and you want to pick one in your code, that's when you need this. So in this is just like a toy example. But for things like when you want to generate a graph and display it in the notebook. Not really that I'm aware of. I think Pill probably has a display function, but this is really, Pill is for manipulating images, and I think one of the things you could do with this is you could give the Pill image object an IPython representation so that it would show up as an actual image in the notebook, rather than just showing up as a bit of text saying image object at address. So you can also, we just showed putting it at the end of an expression here, and then it will appear with the out prompt. So here the out5 variable will be holding this image object. So you can always bring that object back, not just the representation. Then display is kind of like the rich output equivalent of print. So you can just pass any object to this and it will send it and figure out the best way to display it. There's a few different possibilities with images. So if you give an image a URL, then I think this will now generate an HTML representation of that. Yeah, so this hasn't sort of gone and fetched the data and made a new GIF object. This has just made an HTML representation of that points back to where it originally was. And you can also do something similar with SVGs, and depending on exactly how you call this. So if you pass the URL with a URL equals keyword argument, then it will do that. The thing that we showed you, the thing that I just showed with it will make an HTML tag that points to that. If you pass it in I believe this is the data argument. So here I'm just going to inspect the signature, and you can see that the first argument is called data, and if you pass that URL, it will detect that it's URL, fetch the data, and embed that image inside the notebook. So like if we scroll down a bit here, you can see these are two different images from the same webcam. So when the notebook was, when this image was created and the notebook was saved, this was the image on the webcam, and that's now, that data for that image is now embedded in the notebook, whereas this one just below it just has the URL of that image. So every time I refresh the notebook, it shows me this is kind of looking over Berkeley and out towards, you might just about be able to see the Golden Gate Bridge in the distance there. But of course, if we rerun these cells, and so we refetch the embedded image, then that will now be the same as it is at the moment. And so you can do the same with HTML, so you can pass it a raw string of HTML and say display, and that shows the HTML. You can also, so there's also HTML cell magic, which just takes the whole contents of the cell and displays it as an HTML object. And you can also, so things can also do this from libraries, so this is kind of getting into why this is useful. So Tabipy is a library for building tables inside IPython, and if you install this, I need to, so here we're using the bang command again to run a shell command from inside IPython. Then I can construct a table object, and then the table object knows how to display itself as HTML. So that's producing a nice HTML table, so you can obviously, there's obvious like use cases for this in terms of like displaying the results from some analysis or something. And in fact, this is also in the background calculating a LaTeX representation of itself. So if I was to export this notebook to a PDF via LaTeX, then the table would still appear as a nice LaTeX table. And so kind of building on this same concept, you can do JavaScript representations of things. So if I display this JavaScript object where the data is alert high, then it will add that content to the notebook, so that JavaScript will be run. So this is kind of a very easy way of getting JavaScript content from your Python kernel to the notebook front end, so you can do kind of extra things with the user interface. And you can do this very conveniently with, again, a %% JavaScript cell magic, so this will just send its contents over to the front end. And these are, the important thing to note about these is these are actually saved in the notebook. So if I now reload this notebook, so this isn't restarting the kernel, this is just reloading the notebook document, then it should in a moment say alert high, and nope, it's going to prove me wrong. Okay. I guess this is probably because the notebook isn't trusted, yes. So because there's kind of a security hole there of like you can send someone a notebook and when they open it JavaScript runs and that JavaScript could talk to Python code and do things, then there's a trust system, so until you run all of the cells in a notebook, the notebook's considered untrusted. So if I manually mark it as trusted and then refresh, now I should see this high popping up twice. Yes, there's 1 and there's 2. So yeah, JavaScript representations are a little bit weird, but kind of allow you to do some very convenient things. And where do we get to? So here we're going to use the JavaScript object again to load a JavaScript library D3, which is a kind of graphing library from a CDN, and then we'll run some HTML, and that didn't have any output, but now when we run this bit of JavaScript, that can use that library to, so this plot is entirely generated in JavaScript, so this isn't saved as part of the notebook, this plot or this diagram, but the code to create it is. In fact, the code to create it is saved in this notebook now, both as input and as output. So you can also, this is the LaTeX features, so you can display a LaTeX string like this, and this is actually rendered by a JavaScript library called MathJax. So it only deals with a limited subset of HTML. So this math class, you just put the LaTeX in a string. With a LaTeX class, you need these like /begin, \begin, and \end tags around it. And again, there's a cell magic that you can do the same thing with. And like even if the notebook itself can't display all of this LaTeX content, then you can, like if your aim is to export it to LaTeX eventually, then that content will be preserved, so it will end up exporting correctly. You can also have audio, so this is an audio data sample that is now embedded using the HTML5 audio tag. So this is just like, so you probably can't hear this, but it is, like when you click play, it is actually playing audio over the speakers, and that's just like a standard web browser thing now that you can embed these little audio snippets. So that's doing it from a URL, but you can also do it like from a NumPy array, so you can do some processing and produce a waveform in NumPy, and then just display it as an audio thing, and you get something that you can listen to. Yeah, somebody's got it working. And this kind of extends to like anything that you can embed in a web page, you can put inside a notebook. So like a YouTube video. So this code is like, if you go to a YouTube video, then at the end of the URL there will be this like just jumble of letters and numbers. If you copy that and put it into this YouTube video object, then it creates something that will display that. So this is just like a YouTube video embedded, and it all works. And likewise, you can have. So here's an example with. You can have this is using an HTML5 video tag, and this is actually putting the data in the notebook in line. So we don't have a built-in object to do this, but you can do it by just like writing the HTML and putting it in an HTML object. And it seems that the format isn't supported by Firefox, at least on my computer. Web video still seems to be a bit of a Wild West, but as and when that starts working nicely, then you can use it in notebooks. And you can even put like an iframe with an entire page in it. So here, this is just an iframe that contains the IPython website. So it's here, and it's not just a picture, you can interact with it. So I can search for whatever. Yes, it's probably kind of prophetic that I search for docs on the IPython website and it gives me no results. But we do actually have some docs. I think the search is just broken at the moment. Yeah, again, it's one of those things that because we don't use, there's not much. We don't tend to notice when it breaks. Yeah, we also have some special objects that just provide links to local files. So this is just another notebook file in the same directory as this one. So you just give it the file name and it provides me with a link that I can click on and go to that. And you can also, if you do file links with a plural, you can give it a directory name and it will just list all of the files in the directory as things that you can click on. Oh yes, I mentioned before about the trusted thing, but just to reiterate that, if someone sends you a notebook, then when you open it, it is untrusted. So that means that all of the HTML and JavaScript output in that notebook will be stripped out, or it won't be displayed when you open it, so that that person's notebook can't just start running arbitrary code on your computer, which IPython 1 would totally do. We have a CVE that Kyle got us for that. Yeah, it wasn't accidental. That was the design at the point, but then we kind of realized that that is not what people expect when they're opening a document. So yeah, there is now this trust mechanism, and the usual way to do that again is that once you've run all of the cells in a notebook, then your computer knows that any output has been generated on your computer. So it's not necessarily that output is safe, but if it is going to do anything malicious, it has already had a chance to do anything malicious. There's no point in trying to protect you from it now. So yeah, we give you the equipment to shoot yourself in the foot in many ways, but we do try to keep you safe. And yeah, so NBViewer is our website so when you put notebooks on, when you store these notebooks, these notebooks are JSON files that you can just upload to GitHub or put in gists or store them on the internet wherever you want to. Then you can view them on NBViewer. So this is just links to notebooks, but then within NBViewer, these show up as proper notebooks, and the rich output, like the HTML and things, will show up there as well. Yes? Yes, there is. I think you have to... Kyle, do you know more about this than I do, given that I don't know very much of it? I think you have to load them in two slightly different ways that they will work both in the notebook, in the live notebook, and on NBViewer, but it is definitely possible.
Yeah, there's not a clear way to get people ask for themes and other JavaScript stuff in this kind of package to get them to work both as a standalone notebook and what you see in the NBViewer.
Okay, so we're going to go now to a couple more exercises. So if you, on the dashboard page, again, if you go to the exercises folder in this repo, and you go to IPython Kernel, then I think if you start with the rich output exercises, so this is just one output, one example, and it's fairly simple. And then if you go into the custom display logic examples, this goes into a bit more detail about how to add representations to your own objects. So start with this one, and then once you've done that, progress to this one. There we go. Just takes a moment for this to kick in. I just got asked, I did an inspection of the signature of an object while I was demonstrating something. You can do that like inside the brackets of a function signature, press Shift Tab, and it should show you that inspection. So 3 o'clock, I think, is the designated time for our coffee break. So please do go and have some coffee. However, just before you do that, I wanted to point out, Kyle has asked me to highlight this. So if you go to this bit.ly/IPython 2015, and then if you have a GitHub account, put your username here, and Kyle will add you to a demo server for this afternoon's, or the second part of the tutorial this afternoon. So this is just like a collaborative document that anyone can go and edit. So if you go to the URL at the top here, bit.ly/IPython 2015, and then add your GitHub username to the list.
It's so fun to watch.
Yes, it's. And then please do go and grab a cup of coffee, and we'll carry on at 3:20. Okay. So we're importing some things from IPython.html.widgets. I'm getting some warnings because I'm running on master. You should only have the future warning saying IPython widgets are experimental. That's just our kind of, don't rely on these too much. So the high level version looks like this. So we're just going to define a function which takes one argument and prints out that value, and then we're going to pass that function itself. So this is using kind of functional style programming to a function, and we're also giving that function a keyword argument which corresponds to the argument of the first function. I realize I'm using the word function a lot here. But this has now, so this x equals 10 tells interact that x is an integer, and so it will make a slider centered on 10, and I think by default this goes from -1 times the value you give it to 3 times the value you give it. So I can slide this slider in each direction, and each time the slider moves, then it calls that function with the new value. So this is kind of like the super simple example of what you can do with widgets, and there are obviously a lot more things that we'll get to where this is possible, but the key thing is, like, I'm defining some UI element in JavaScript, and as I interact with that, that's triggering a Python callback, which can, in this case, it's just printing the value I give it, but if that can do arbitrary logic. If I want to print the square of the value, I can totally do that. So here it's squaring the number from the slider, and you can see that negative numbers squared go back to being positive numbers. And I've now lost keyboard focus, but there we go. So you can give it different kinds of things. So when I give it an integer, it makes a slider from that. If I give it true or false, a boolean, then it makes a checkbox. And where's the... That's interesting. It seems to be giving 0 or 1 instead of true or false. I'm not quite sure why that's happening. Is that happening for other people as well? No? Okay, so that must be something we've broken in master since since 3.x. Good to know. Sorry? Excellent point. Thank you. That is because I have told it to square that. And so, bit of Python trivia for you. It might come in handy if you're at the Python trivia dinner in a couple of days, is that true and false are actually subclasses of the integers 0 and 1. So you can do maths on them and they will behave as 0 and 1. So true squared is 1. I don't know if you can do minus true. This probably isn't the time to find out. If you give it a string, then it produces a text box, and again you can see as I type in the text box, the results update live. Sorry? You can do minus true. Cool. And you can do the same thing with more than one argument. This isn't limited to just a single argument. So here I have a function with 2 arguments, and now I'm using interact as a decorator. So a function that takes another function can be applied to that as a decorator, and we've done some trickery with how you pass arguments to it to make sure that it works in a couple of different ways. But yeah, so you pass these kind of specifications to the decorator, and then wrap the function. And again, as you interact with either of these things, it updates live. And here this is also demonstrating that floats, like integers, give you a slider, and they work a bit differently. So they're actually different kinds of widgets in the type system. So this is a float widget. So, and I think the default step size for float widgets is 0.1. So this moves in tenths of a unit. If there's a parameter that you don't want to have interactive, then you can wrap it in this fixed thing for interact. So this just tells it, like, this, we don't want this to be interactive. So I can interact with P, but Q remains at 20, and no widget is generated from that. So these things that we've been showing, we call these widget abbreviations. Ooh, shouldn't walk over there. So these are widget abbreviations. So when you give it like a number or a boolean or a string, and there's a couple of other things, like you can give it a tuple of 2 or 3 numbers to define different like variants of a slider. You can define like the min and the max and the step, I think. These are kind of shorthands, but you can also give it a full widget definition. So widgets are objects that you can construct. So these are just classes that you can instantiate. So if you want to precisely control how you're making a slider widget, then you can instantiate widgets.intSlider and give it a minimum, a maximum, a step, and a value. works just as you'd expect. So here's the full list of different kinds of abbreviations that you can have. So true and false give you a checkbox. A string gives you a text area. There's 3 different ways to get each kind of slider. You can have a single value, in which case it will do -1 times that, 3 times that. You can do min-max or min-max step. And I think in both of those cases it will try to start it in the middle of that range. And then if you do a tuple, a dictionary, or a list, I think, then it will give you a drop-down list of options. And if that's a dictionary, then it will show you the things that it shows you in the drop-down are the keys of the dictionary, and the things that you actually get in the callback on the Python side are the values of that. So here's an example. So this is now an integer slider with 0 to 4. You can do 3 tuple in order to specify the step as well. So now we can only move in jumps of 2 at a time. If you give it a slider with floating point values, if you give it a tuple with floating point values, then you get a float slider instead of an int slider. And again, you can specify the step as the 3rd value. So now you can step in hundredths of a unit. So you can also, if you're doing these abbreviations, you can, with the sliders, you can specify minimum, maximum, and step with the abbreviation. If you also want to give it a default, then you can just do that with a default value for the argument in the function definition. If you're not defining the function, then you have to go into constructing the full slider definition. But if you are defining the function, you can just do this. So this will start off at 5.5, and that's mobile. And again, if you have a tuple, then you get a drop down. So you can just choose between these options. And if you have a dictionary, then you choose between the keys, which I think have to be strings. I'm not entirely sure about that. And the Python callback gets the values, yes. I think you would have to get into constructing your own. No, I think you could. I think you could. Yeah, so for interact, I think that's the only way to do it. But for, if you were building a more complex set of widgets, then you could definitely, if one widget was updating the list of values for another widget, then, all of these things you can set on the widget after the widget is constructed. I think we'll get into that in a moment. If you're doing this on Python 3, then you can also specify the abbreviations or the widget definitions using function annotations. So any parameter you can put colon and then the widget definition or widget abbreviation after it. And then when you call interact, you don't need to tell it what kind of thing that is. It will pick it out from the function annotations. We also have interactive, which is interactive builds the widgets to do the interaction with the function. Interact just calls interactive and then additionally shows the widget. So you can see that it builds a box widget, which is just a container that you can put other widgets in. And you can see that has two children in this case, and they're both int sliders. And then you can use the display function that we used in the last section to display those widgets. But, oh, so the other thing that interact does is that it wires up displaying the output from the function. So this is, I believe, calling the function, but its output is not getting displayed anywhere. Did we actually? Yeah. Oh yes, that's returning. This function is returning the value from the. So w.result is the result of the function associated with that interactive widget, and w.quargs is a dictionary which shows you what the current values are set to. And if I change this and rerun that, then you see that the value has changed. So interact is kind of the high-level interface to using widgets. And just before we go into exercises, I am going to look a little bit at some of the lower level stuff, interactive widgets. So again, we're going to be naughty and import from widgets import star. Okay, for some reason it doesn't like my Python 2 kernel at the moment, so let's switch this to my Python 3 kernel. There we go. So this is what we get if we just construct and display an int slider. So it's displayed just because it's the last thing in the cell. So if the last thing in the cell is an expression, we always try to display it. And that goes for widgets as well. So this is just a plain int slider. It defaults to 0 to 100. And it's not wired up to anything, so nothing's happening as I slide it. And you can explicitly display them with display W. And so the cool thing to notice is, like, I created a slider here, and now I've displayed it twice. So these two are instances of the same slider, which means that if I slide one of them, they'll both slide. And in fact, this isn't even round-tripping to Python. This is synchronized purely in the JavaScript side. So there is a single widget model, and there are two views on that. And when I update either of them, that updates both views. I guess that's just what it's describing here. Widgets also have a close method, so that was a bit quick. Oh, yeah, I can't display it again now that I've closed it. But if I recreate this W widget, if I display it there, then when you call close, the widgets disappear. So widgets have a value, or at least all of the widgets we include that you can use with interact have a value. If you define your own widgets, that's not necessary. So once I've moved the slider, the value corresponds to the position I moved it to. And if I set value on the Python side, then if you watch the slider, you'll see it updating to the new value I've just set. So the way that widgets work is that there is a collection of attributes which you can inspect by doing widget.keys, and these are synchronized between the between the kernel and the front end. So there's a bunch of things that are related to how the widget is displayed, like the border and the margin and font family. And there's some other things that are related to like the widget machinery itself, like message throttle, view name, view module. And then there are the things that are actually specific to this widget. So this is a slider widget, so you can see it has min, max, and so description is like a label that will be shown next to the widget. And somewhere in here there should be value. Oh yes, there's value, and somewhere there will be step as well. And you can set initial values for these by passing in keyword arguments, as we already saw. So here the text, single line text input widget has a disabled property, and you can set that by passing in disabled true. And then if I actually redo that, so I now have a handle on, so here you can see it's disabled, I can't click on it, but now if I do t disabled false, then it gets enabled. So, and in a drop down, going back to the question earlier about populating this from a database query or something, then the list of available options is another of these synced properties. So you can either pass that in at construction time, or you can modify that after the fact just by setting attributes like this. And it will, whenever you update it, it gets synced. And so you can also link widgets together. So this is now connecting things up on the Python side. So I now have three different widgets that all have a floating point value. So float text is just a text box that displays a floating point number. Float slider is a floating point slider, and float progress is like a progress bar that you can, works like a slider, but you can't, it's not interactive, it's just for output. So these are linked together, so when I interact with one of them, that sends an update to the Python side. The Python, like the callback from those, tells the other two to update, and then those will send messages back to the front end saying, update yourselves. So if I move the slider, then you can see that both the progress bar underneath it and the text box above it update. And you can also see that if I change the text box value, then it's updating the other two. And so the link object itself has an unlink method which will disconnect them. So if I run that, then now these are no longer interactive. These are no longer talking to each other. So I think now would be a good point to try to do some of the widget exercises. So again, if you go into the exercises directory here, and then go to interactive widgets, and I think so this is somewhat up to you which you want to work through, because we won't take too long for this, because we want to give Carl some time to talk about things. But so the interact exercises are the first bit I showed with the interact function that makes it very simple to like call a function with values set interactively from widgets. And then the widget exercises are a bit kind of lower level and probably more interesting if you want to build your own interfaces using widgets. So again, we will wander around, and then in, I guess, probably what time? I think we're here until 4:40, I believe. So in 15 minutes or so, we'll hand over to Kyle and talk about Jupyter Hub.
How'd everybody do with the widgets? Sweet. So since some people asked about kind of motivating examples for the widgets, I'm going to show a custom widget that I have. And this is in a library called Widget. I just want to show this real quick. And so this creates like a binary view of some amount of data. And then what I can do here is I'm sliding through the width at which I look at that data. All right, and so this is Canvas. It's all in JavaScript. And so like I'm updating that in real time. Like I can read in whole files, and then I can change the width at which I look at that data. In this case, I'm looking at user bin base64. So I'm looking at some executable, and I can tell that there's like a likely data sections, a whole bunch of zeros, and like the executable header. And so like people would use this kind of interface to do malware analysis, where maybe they want to see like how did they structure some of it? Was it packed? Other things like that. And so this gives you just a general nice way for you to build a widget that does something. And in the background here, there's a whole bunch of custom widget work that draws on a canvas for you and allows you to do this in performant ways. Like without you having to build a whole website just to play with whatever your data is. Yeah. Cool. So now I'm going to talk about running a notebook server. So as you're running it on your laptop locally, it's running on local host, runs on some port, unless you're running it somewhere else. But if you put it up on the web, you're going to want to secure it with a password and put SSL on the front. And so there's an option to create a password within IPython. So do from IPython.lib, import password, and then you can either get it there or have it requested. Yeah. So you pass it whatever your password is, and you get back a SHA hash, and then you add that to your config. This is all located within that same the examples that we started out with. I should have said that, which is running a secure public notebook server. Right. And just the same, you can also create SSL certificates or get them from your favorite provider. And this is a hard problem for people across the web, no matter what. Like you either have to purchase certs or create a self-signed cert and manage it. But if you're going to put it out on the web, you definitely want to secure it. You definitely want to put a password up. I'm just going to skim through here. All right. And so I'm going to kind of talk about the future. Let's see. There we go. And that's the multi-user notebook servers. And so Jupyter Hub is our multi-user server that manages and proxies multiple users across like an entire installation. And they get their own single user notebook server that they can do their work on. So you might have your own cluster that you work on for work, and you want other people to just access the cluster, but like, you know, provide them SSL, provide them their own domain, let them log in how they want to. And so like, here's an animated GIF where people can get to it. And while I'm doing that, so if you saw in that Etherpad, there was this URL, so demohub.jupyter.org. If you got it in there in time and I didn't miss your username, you can go to this URL now. You just need the first part, the rest will autofill. demohub.jupyter.org. And it'll probably ask you to go to from GitHub to authorize the application. And that's simply so that we have a token so we know you're the user there. What happened? Has anybody gotten on? Any luck? Luck. Cool. What's that? A 403. What was your can you spell the RIGDON?
No, because it's GitHub. I don't know, let's try something else. Maybe it does. Was it R? What capitals do you have? I guess so. Okay. Well, there's a bug. File that to the tracker. Yeah, and so in this interface here on Jupyter Hub, like I'm just adding direct GitHub users. So when you provided those, I just added the username, and then you can log in directly to it. Yeah, so that installation doesn't have much on it. It's just a simple one that just has Python. I don't think it has any of the SciPy stack or anything. The way that this works is we have that multi-user hub, which is the tornado process, configurable HTTP proxy, and then however many notebook servers launch for each of your users. And so this is based on node HTTP proxy. The config proxy is, and it'll route to localhost if it happens on some external IP, et cetera. And on there, it's like, so if the user comes in, their username was 123, it's actually going to whatever port their notebook server runs on. It just runs as a process for that user. And we just have an API that adds the routes directly. Like you don't see that when you run Jupyter Hub itself, but that's what's under the hood. And so Jupyter Hub actually launches the proxy for you, forwards all requests to the hub by default, and then it'll handle login and spawn those servers when it needs to. And then, right, the hub itself configures the proxy, and the proxy says like whether or not you can get to that route. The default authentication model, if you install it out of the box, is just the normal Unix credentials. But there's also GitHub OAuth, and that's the one that you played with now. And you can implement other ones. MediaWiki is putting together their own that uses MediaWiki auth. Thomas, do you want to grab, or do you have a question? Yeah, I don't know. I'm guessing, I think it's configurable what endpoint it hits. But that's a tricky question because GitHub Enterprise, sometimes their auth is through like LDAP or whatever's integrated on your setup. So I haven't tried. Yeah. Yeah, yeah. So demohub.jupyter, but JUPYTER.org. Yep. Yeah, IPython is a remote execution framework for giving anyone access to your entire system. In the case of this one, everyone's in a Docker container, and then there's specific security settings on turning off inter-container communication, and then you don't launch as the root user. So you have the permissions as if you're running on the box, but it was within the context of the Jovian fake user. Yeah, so you can go and remove all your files, that's fine. Yeah, you can change path to wherever you want. I mean, it's sandboxed to the level that Docker will let you sandbox, and I'll actually get to that now. So I'll jump back to it, and then we can keep running on through. Right. So, like I was saying a second ago, the spawners normally just runs as a process. Like the default one is just going to launch IPython Notebook itself. But one of the other spawners that's been implemented is to actually launch each user within a Docker container. And so they get whatever's inside that Docker container. You can give them a full environment, so you give them the full SciPy stack, you give them everything that Anaconda has. Someone has an image out there that includes the base Conda install, and then another one that adds on all of Anaconda. So your users can Conda install whatever they want, but and they don't have to have root, and they're able to install whatever packages they need to do analysis. So for Docker, it means they're sandboxed up to the level that Like it's a full file system that they can change, and if they had access to it, they could remove whatever they want out of Etsy. They could delete whatever files they want. They could shut down their own server, and then you just launch a new one. Like that's also a protection so that your users are allowed to do stupid things and you not have to worry about it. Or yourself. I mean, I definitely have rm-rf things from RPM installs where the first variable was not defined. So at least one real-world implementation of Jupyter Hub right now comes from Berkeley. Jess Hamrick put together the computational models set up for her class, where people are able to, like her students are able to work on assignments. They all share those same assignments, and they just log in. They don't have to do installs. It makes it really easy for them to just get straight in and start working with it. And the way that this one's laid out is that there are actually a whole bunch of nodes that they can do computation on, and all the notebook servers run on. And underneath the hood, it uses Swarm for clustering, which is Docker stuff. So it's almost like there's a soup of buzzwords and everything else that put together to make this full system. But each notebook server will launch on a node, and then they just use NFS to share the documents between all of them. So if a user logs in and like their server changes or one comes down, all their data is on a separate node that pulls up as they get access to their server, and they run as their individual user, but within that Docker container. And it's really easy for the class to do all their grading because, like, since it's on NFS, like they can just look across all the students' assignments right there as they're editing them and everything else. And things have been going mostly without a hitch, and the whole class has been pretty successful with that. Like I don't have exercises for these, but if people have more questions about Jupyter Hub, I'll answer those now. I'd say the Docker spawner was fairly easy to write, but that's like with some knowledge of the DockerPy stuff. I think Docker spawner is the only alternative spawner that's out there, so it's probably the good reference. I guess I don't want to say that it's easy, because to me it seems easy, but I think yeah. Yeah, that's kind of up in the air. I've got a bunch of different ideas, so come to me. I'll gladly help and mentor on any of that stuff, so find me. So I added the rest of this to running the notebook server while you all were having fun during the last one. So you'd either have to git pull and get the fresh stuff. Yeah, but it's been pushed up. Yep. I'm a tricky person. Yeah. The other one I'm going to talk about was already in there.
So this server model is already, I mean, can we make our own servers, or we have to go to already established server that you did?
No, so you can make your own. And right now there's at least 2 Ansible setups that outline how they're doing their entire deployment. And like you can follow the Jupyter Hub user guide. And so within there, I've linked it, but I probably should have said that as well. But this is at, here, I'll pull it up. So this is at github.com/Jupyter/JupyterHub to get access to all of that. I mean, you can launch it as is. And like you're on a Mac. I should have repeated the question. So he's asking, like, do we need to use an existing setup to use the Jupyter Hub server, or can we launch our own? And so the whole purpose behind Jupyter Hub is to provide people a way to manage some multi-user environment with the IPython notebook. So a whole lab team can work together, but not have to administrate them all. So yeah, so it's all available there at Jupyter/JupyterHub. Did that answer everything? Okay, cool.
I mean, this is when we start the way. I mean, I have to
Okay, and then we have one other option, and this is for more like ad hoc. Maybe you're teaching a class. Maybe you just want to show a demo of some of the code that you have. And that's the temporary notebook system. And so if like you want to try that one, you can go to try.jupyter.org, and that'll give you access to a brand new IPython notebook. And so if you hit that one, bam, no login, just straight to a notebook server. So again, that was try.jupyter.org. And so this one's similar to the Jupyter Hub setup, and that it's still using the config proxy, and it launches Docker containers. The only difference is that it deletes the users as you get there. And so when I look at try.jupyter.org, I've got one server, and so like let's say that I took all of these, and I just deleted all this content. Yeah. Oh, fine. Okay, so we just deleted a bunch of notebooks. I just go back there again, brand new notebooks. Because under the hood, when I'm hitting that, I'm getting a new user every time. So if I delete this, so you see it says VJ blah, I get 33AVWXO. So just a new user got allocated each time. And the way that this works is that you have those Docker containers, but then they're pooled up so that they're ready to go for the next person to hit the server so that they get access to their own environment to play with this stuff. Yep. Oh, I didn't link that, did I? I feel bad now. So this one's also on GitHub under Jupyter/tempNB. Yeah. So this one was originally created just to do a live demo for readers of Nature. And so there was an article about IPython, and they asked if we could give a demo, and so we came up with the temporary notebook system. So if you click here, so I just searched for Nature IPython to find this. Then in there we had a full demo of the notebook server itself, which looks really weird on the screen. But yeah. Okay. Any questions there before I go to some kind of backing Jupyter IPython stuff? Great. Okay, so we've already been working with IPython, and we're just using Python. We're at PyCon after all, but we should talk about some of the infrastructure that's behind it. Like how is your code running? What happens? And how are we sending, like from this web browser front end, how are we executing code in Python itself? So when you type IPython, you get the original Python interface. You get the original IPython interface running in the terminal. And roughly speaking, there's this loop that's going through that takes in code that you've input and executes it for you. It's much more complex than this because of like it has to handle multi-line and all sorts of other things like tab completion, read line, the magic commands, and all that. But I mean, roughly speaking, you prompt the user for some code, and after they've entered it, you exec it in that same process, and that's called a REPL. That's read, eval, print loop. So give you some feedback from whatever interactive session you have going. And all the other interfaces, like so the notebook, we also have the Qt console, and the IPython console, and the terminal, and any other third-party interface, like can't remember the names of them. Like they all use this IPython kernel, and so that's a separate process that runs your code and makes doing all your computation possible. The front ends, so like the notebook itself, communicate using JSON messages over a 0m cube. And so the protocol that they use is one that can be adapted and used for any language, right? So here you've got standard in, standard out for how you're communicating with your process. It executes that Python code, or I mean, it sends that code over to run it, and it's communicating over 0MQ back to some kernel. Right, and so you could even connect to more than one front end at the same time. So there might be one kernel that's running, you have a notebook server, and you have a console that are both interacting with it. Right, the options for what you could do that with that are much more interesting than just the notebook and the console. There may be some other separate widget that you're running, or something else. But they all have access to the same variables and everything. Like, the motivating factor for this is that you can have alternative front ends that use the same kernel, you know, and each having their own different representation of what like a rich display is. And by doing it this way, it also means that we can support more than one language. So that's the whole switch over to Jupyter in the name that you see in the upper corner, and is really just like, we want to be able to execute code in a language and work across the same protocol. And so if somebody wants to develop a kernel for another language, there's two basic ways that you can do that. There's the wrapper kernel, which uses the same communication machinery from IPython and just implements the core execution part. And then native kernels, which implement execution and communications in the target language, right? And so there's kernels for R and Julia and something like 22 or 23 other kernels. What's that? Are we over our time now? Oh, 30 languages, I'm sorry. Yeah, so the wrapper kernels are really much easier to write. You can get access to a bash kernel, and I think, so that's Thomas's kernel that he wrote, and then I've seen people add in like kind of a display way so that they could show images and everything. There's some phenomenal notebooks for looking at those. But then also iJulia and iHaskell. And so you can install all of these kernels. Normally when you click up here, like, you can change the kernel that you want or launch multiple notebooks. And on that same try.jupyter.org site, you can select to start a notebook that's Julia or R, and you can play with that from there. Right, but the notebook front end does something extra, and that's in addition to running your code itself, it stores that code and output in the overall document and saves it on disk with that IPyNB extension. Yep. Anybody have questions over those? Oh, with the multi-user setup? Yeah. And we have 10 minutes left. We could go after that. It is not in that section. Yeah. Okay. Right. So IPython itself, just as IPython, but now with other languages, has a parallel computing framework that you can work with. And if you've been using for the notebook for a while, you probably noticed this clusters tab. I've gone, what is that even for? Right, and so I guess, so the way I navigated to this is from that same repo that you were in before, under examples and parallel computing. I've got, this is our index here. What's probably the best one for us to start with? Let's start with a motivating example. Okay. Okay. So we're gonna run this Monte Carlo simulation on pricing. And so we've defined this function. Let's say that we don't necessarily know what the function is. We're just going to skip past it. And so I could just run that function itself that I care about. And so I'm going to use time it. It shows me how fast I can run that. But let's say that we set up a client. And the way that I imported those at the start is IPython.parallel import client. And so this is just configuring the original parallel that we're going to work with. Right. Right, and so in this case, it says, oh, hey, I don't have a client yet. I'm going to go back to the clusters tab. Let's give me 8. Start. Maybe I do need to go back. I'm sorry. I guess maybe I do have to start with the first one then. No controller. Row. Hey, Thomas. Do you think you could work at this? Apparently, my system is not set up for it, and I was hoping temp and B would have enough. I was hoping I could run through some of the parallel stuff to show people. There we go. Sorry about that. Okay, I was apparently looking at the wrong tab, so I had launched a cluster somewhere else. And I think I'm going to kill these tabs. Okay. Okay, so in the clusters tab here, right, click a number of engines, And so that just means, like, that could be the number of cores that you want to work against. It might also mean if you have it set up to do SSH for the parallel client, you're going to work across a whole bunch of different machines to get engines. And so in this case, I'm just going to launch 8. And so let's go back in there. Oh my god, I keep clicking that one. Okay. Cool. So in this case, I'm going to set up a client. And so I'm giving a view into some data that I want to publish across several of my clients. Okay. So across each of the functions, I'm going to give them this dictionary that contains, that's just A to high, right? And so here I create a client. There's a client that lets me work with any of the engines that I have available to me. And then I'm getting a direct view onto that client itself, saying, oh, hey, give me all of them. I don't remember what dv.block is. I'm not sure if I would get any. No, because it's just a type. Right, so I get a view into those. And so I'm going to go ahead and publish data across each of those to let them know that this variable is that. And then on that view itself, I'm going to asynchronous. What's that?
I think what this is actually doing is this function gets sent to each of the engines, and then this tells it to run on each of the engines. So it's actually the engines sending this value back to the client. Which, possibly this wasn't the best example to pick. I don't know what is the best example to pick. So
Yeah, because usually we have like a certain flow, and I was worried it was going to start too low. Oops. I mean, the mapping one's decent. This might be the best one, because then we're working across all of those. Temp and B doesn't give you many, it gives you like 1/1024 of the entire system.
still probably shouldn't take that long to do like 10 people next week. Oh, it might be stuck with this.
Oh, because the,
Go back to the first page and just start from the first.
might as well just restart this one. No, I'm still going. Oh, did I? Nope. It's still going. Which one? This one?
That was, I think, from like what was saved in the notebook from last time.
Oh yeah, and I just overrode it when I executed this cell too. So right now it's running this one, and then it's going to run that one next. Let's see. I'm going to try my system instead. There we go. Okay. Okay, sorry. So I'll come back to this to give us the map and the parallel function decorator. So this is under parallel decorator and map. I just started a new cluster. I'm doing it on my local machine instead of that one. I'm not sure what's going wrong. Right, so I get the client. The load balanced view, I believe, I'm gonna pull that up. Using all engines. So you can target which ones you specifically want to do, and if you do the load balanced one, it should distribute across the jobs evenly. And so let's say that we do a map across, so that view that we get there, so if I do V here, yeah, V dot, cool. Yeah, so across all of the machines that I have, I just want each of them to multiply those. So a simple default map, and I'm just gonna multiply out, 2 times x for that range, right? And so I get 0 to 18. And across that same view, but I want to map it asynchronously, and so that means that different results can come in at different times. So one engine might finish before the other, but I still want to get results back as it goes through. And so the first thing I'm going to get back is what message IDs that I receive. Right. And so these are the IDs for the actual messages themselves. And then I want to get a specific result, and so I just ask to get back that one. And when it's doing this in this default map way, so right, so I'll look at, so how many jobs did I get here, right? I'm looking at, right? Because I basically submitted 10 jobs, and those got load balanced across all the engines that I had. So I only had 8 engines. I could have had a lot more engines. But they were each given that function and then some amount of data that they're going to send to each of the cores, each of the engines that it's running across. Yep. Yeah, I think. Was there another hand? Cool. All right, and so there's another decorator that you can use too. And so remember our view that we had up there of all of our engines was called V. So we're going to do @v.parallel, and then we're going to block to wait until all the results come back. That's a result. So if I declare, so if I put this decorator in front of this function here, so I've got f of x, I can now just run f.map instead of saying map of, or so like above, we did on the view map it and then give it the function. Instead, you can say the function map with the rest of the stuff. Great. Yeah, so each of these is a different process. It opens up an IPython kernel for each one. Yeah, so that's done through the 0MQ sockets. Yeah, at least in this case, you have to make the decision for how, like this is the most immature way to send the data over, because you're not saying how is my data partitioned, like how do I want to break up this job to make sure that there's some co-location. And there, I think the section on the data view help you get through that, but I'm not completely sure. Thank you for bearing with my ad hoc pull-up of this stuff. Cool.
That's our allotted time, so thank you for coming. We will stick around. We'll be happy to answer more questions and things if you want to follow up with questions. But you are free to go now if you want to get the telephone questions.
Thank you all. Yeah, and if anybody has questions, feel free to find us throughout the conference to help with stuff, and we'll certainly be there for the sprints. So.